When the axes of a graph are simply labeled x and y, the ratio of vertical change, the rise, to horizontal change, the run, is the rate at which y is changing with respect to x. This ratio is a measure of a line's slant or slope. We let m stand for slope, which is the ratio of the rise over run, the vertical change over the horizontal change. And here's the formula. That formula is coming from 2 points from the line where we're describing the rise, the change in the y values, over the change in the run values, or the x coordinates. This formula that's in the numerator is the description of the two y values, and we use subscripts, or these lowered 1's and 2's are not exponents but denote the difference in the points. We're taking that change between this y value from this point and this y value from the second point. Likewise, we do the same to calculate the change in the horizontal displacement by subtracting the x components. X sub 1 and x sub 2 are here with the difference formula on the denominator of the slope. Let's take a look at calculating the slope of a line given two specific points. So here we have a line that's running eventually between the second and the fourth quadrants. It will have a negative slope. We want to know what that slope is. Our ratio is rise, which we're dropping. If we're going from the point here on the left to the point on the right, we have to drop. In other words, rise a negative for a positive run. And to calculate that numerator then, we'll take the two y values and find their difference. So y sub 2, in this first example, we'll let y sub 2 be 4 and y sub 1 be 1. And notice we're subtracting a negative 1. Likewise, we will set up our denominator. X sub 2, because we started with this 4 as our first y, and call it y sub 2, this is the corresponding x sub 2 that needs to be started with in our slope formula. So we have a negative 2 minus the other x coordinate, which is negative 1. Simplifying, we have a minus in the numerator, which is plus. 4 plus 1 is 5. In the denominator, negative 2 minus 1 is a negative 3. And so here we have our slope of 5 over negative 3. This also could be written as just a negative 5/3. We are rising a negative 5 for every 3 that we are running in the positive direction to generate this line, or as a description of its steepness. Now, nothing says we had to use this point as our subscripted 2 values. We could have equally as well started with this point and describe the slope as we're going from this point to this one, which would mean we're rising a positive but running to the left, which would be negative. Still a negative slope. And let's take a look at what that looks like. So here, our change in our y values, starting with this as our first y, we have negative 1 minus 4. Because we're starting with this lower point on the right, we will also start for our change in x with this x value of 1 minus this x value from the second point of negative 2. Simplifying here, negative 1 minus 4, or plus a negative 4, is negative 5. The negatives cancel out in the denominator, leaving us with 3. So again, we're getting that same negative slope, a ratio of rise of 5 over run of 3 in the negative direction.